Let's send it to the cloud. All right. This is partial fractions. So some of you may feel like this section is difficult because it's very algebra heavy. As soon as we move on from this section, we're going to not talk about partial fractions anymore. So it's only going to come up this one time and on your test. That's it. Then we're going to move on to trigonometry and pre-cal. Don't ask me why the book is set up that way, but we need to talk about it. So the cool thing, what this does, what is partial fractions, right? So basically, if you have a fraction like this, can you see my little pointer? If you factor the bottom, thank you, appreciate that. If you factor the bottom, you can separate them with addition. Usually it's not something you can do all the time, but there's a theorem in the book that says that if you have factors at the bottom, there is some number that exists for the numerator a and the numerator b that can be solved for that will make this equal. So basically you can just separate fractions anytime you want if you do the hard work of finding the a and b. And this is case one. We're going to go through case one through, I don't know, like 6 or something. Okay. And right now, notice when you look at this, they skip all kinds of stuff and it looks like Chinese. So let's show all our work and go slowly and figure out what's going on. Okay. So let me write that down, get my pen. So case one. Oh, here it is. It's called distinct linear factors. So notice how these factors here are distinct, right? They're different. So when that happens, you can just pick A and B and put it on top. So let's start right there. Let's see. I ran out of line paper, so I'll just write big. Case one. Let me switch over to the camera. Can you guys see this okay? Okay. Thank you. Distinct linear factors. All right. Okay, so the first step you do, the first thing you want to do is factor the denominator. The section is going to assume you remember how to factor trinomials. Since this is a basic type, you just look at the 6, right? You remember? Look at the factors of 6 that add up to the center term's coefficient. So what factors of -6 add up to a +1? So we did this way back in the day. Right, so -2 and 3 would do it, right? +3 -2. So 3 times a -2 is a -6. 3 plus a -2 or 3 minus 2 gives me the 1. So that's why I know for sure that we're good. Okay. So because they're linear, because they're distinct, you can write it this way. Just some A, some B. The order does not matter. Okay. If I choose to put the A over here or the B over there, it doesn't matter. Although if you decide to switch this and you try to compare your work with somebody else, it will look different, but the final answer will be the same. It'll be confusing, but as long as you know, it doesn't matter. And at the end of the day, the final answer will be exactly the same. Okay. It's just that their A would be B and your B would be A. So it's like, what's going on here? It just depends how you define it. All right. So here's step one. So on the left-hand side of this equation right here, so I'm going to go ahead and write it here. So yeah, B. Dang it. Let's use the prime factors. Sorry about that. Okay. So step one, first algebra step at least, multiply both sides by the LCD. Do you guys remember what LCD is?
Largest common denominator.
That's close. It's least, the smallest one. So we don't have to think too hard here because the least common denominator, the LCD, is always on this side. So usually we got to think about it, but in this case, in this section, you will always multiply by whatever the heck is on this side. Okay. So I'm going to multiply both sides by this guy right here. And it looks like it's at top. Technically it's to the side, but it doesn't matter. You see what I'm saying? Like it's technically to the side. But at the same time, it's the same. Okay, you guys read that okay? I know my handwriting is not the best. So the left-hand side will always cancel everything. The top and bottom will cancel out, leaving you just with that 5, or whatever's on top, basically. This will happen every time. Only the numerator will be left, equal to. Okay, so all these are gone. All right. Now, over here, only one of them will cancel, right? You see this? Only the x plus 3's will cancel. So I'll be left with x minus 2 times my a. X minus 2 will cancel on this guy, so I'll be left with x plus 3 times my b. Any questions as to what happened on the algebra from here to here? Is that all right? All right.
No questions.
Okay, just let me know. If I don't make any sense, just tell me. I won't get mad. I'll repeat myself or say in a different way. So at this point, there's two methods that we can use. I'm going to show you the method that works every single time. So
This
what
is
you,
counting step 3.
yes, I would say step 1 was multiplying. Yeah, this is step 2 right here. Let me write this better. Luckily, this erases. And I'll scan this and send it to you probably right after class as well. And I'll upload the video as well. Okay, thanks for reminding me on the steps. Sometimes I forget. So step 2, simplify and group. So we're gonna have 5 equal to x minus 2 we had earlier times x plus 3 times the b. So just go ahead and distribute. So we can distribute backwards if you want. Is that weird? Or no? The same thing as having it in the front, right? Distributing this way. You see that? So a times x, a times negative 2, b times x, plus 3 times b. So now we'll group everything that is the same. So here's a simplification. Now let's do the grouping. Ax minus or plus bx minus 2a plus 3b. So I grouped everything that had an X. I grouped everything that did not have an X. And that's the only two types that I have in this example. So once you're at this point, we're going to start step 3. It's called equate the coefficients. So this is, I guess, a little weird. So we're going to create equations by equating the coefficients. So I'm going to try to show an extra step if I can here. I'm going to factor the X, but I'm going to factor it on the right side for no reason. So do you agree that the A and B are some numbers, some number, I don't care what it is. So this could be like a 7x, right? And you would say that 7 is the coefficient. Does that make sense? This is some number on the X. Okay. And these are just two constants. So when I say equate the coefficient, I'm going to equate this coefficient with the coefficient of an X term on the left-hand side. Do we have any X terms on the left? So then what you would say is this coefficient is equal to 0. There is no X terms over here. Then you would say the constants are equal to the constant, the 5. Does that make sense?
Could you go over that one more time, sir?
Yeah, so we have, these are constants, right? Because they have no X term. So negative 2a plus 3b is equal to this 5. That's what equating the coefficient means. The coefficient of the X is a and b. So these are the X terms. You set equal to the X term on the left-hand side. Since there is no X, you can pretend there's a 0x over there. So you set it equal to 0. So what you do is you end up creating a system of equations that will solve for a and b, which can then do this for you. The whole goal of, right, what the hell are we doing, right? The whole goal is separating the fractions and finding some a and b that makes this true. That's what partial fractions means. That's what we're doing. We're looking for those a's and b's that makes it equal. Okay, so at this point, you can use a calculator. You could use elimination. You could do substitution. It doesn't matter. I don't really care how you solve for a and b. It's up to you. Do you guys have a preference?
Substitution.
Okay, let's do substitution. Let's say, so if I take equation 1, right, I can say that a is equal to negative b, right? Does that make sense? Just move the b over. So if that's the case, I'm going to plug in that a right there, this b over here. So is that okay, or let me know. So the a will be substituted by negative b. So this guy is going in there. Okay. So this is way back when you first did substitution. So then I'm going to have negative, negative. So that'll be 2b plus 3b equal to 5. So that'll be 5b equal to 5, which means that b is equal to 1. And if you don't like substitution, they could do different methods. They could do elimination pretty easily, right? First one was a and b, right? Equals 0. So what I could do is say, you know, I'm going to eliminate the a and multiply equation 1 by 2. So I change the first equation by multiplying by 2. And then just go ahead and add the equations. So -2 minus 2, 2 plus 3. And I didn't show where that 1 came from. You just divide both sides by 5. So B is 1. Does that make more sense, or do you like the substitution better? Personally, I like the matrix and just punch it in my calculator, but I don't really care how you do it.
Substitution.
Yeah, substitution's making more sense personally.
Yeah,
Yeah.
this doesn't make sense, this one. You see what I did? I just multiplied the first equation by 2. And then I add this first equation to the second one and got this. I mean, I don't care how you do it. I'm not judging you. You do whatever you want. I'll be happy. I just want to make sure I didn't make sure I explained it okay.
This might be a stupid question, sir, but like, if substitution is the one that's making the most sense to me, will that universally be useful? Or would I at some point need to rely on the other method?
I would not suggest substitution when you start having A, B, C, D, E. Because then it becomes a real pain. That's when I would say, you know what, pull out the graphing calculator or use a solver. Because life's gonna suck, you know. But let me show you on the graphing calculator. And on the website too, just for fun. And here's my, see, hopefully this thing is charged. Oh yeah, it is cool. You do not have to buy this. So yeah, I might need another page. You guys cool with this page? Can I turn it?
You're gonna share it later, right?
Yeah, I'm gonna send it to you in a little bit. I can turn it back in a second too. So I just need a space to write the equation. So A plus B equals 0, and then we had negative 2A, right? Plus 3B equal to 5, is that what it was? Yeah. So back in college algebra, we said that we can change this into a matrix, coefficient matrix. So this is the A column, this is the B column. You guys remember this? And this is the constants. That familiar? Or no?
Yes.
Vaguely.
Vaguely. It's like, I'm going to read you the notebook over and over again. All right, so if you go to if you hit second, I have to show you the buttons. Second, and then matrix. See where it says X inverse right here? If you have a TI-84, you can go in here and create your own matrix. So just go to edit. The dimensions of this matrix is always row by column. It's always row by column, which is 2 rows by 3 columns, right? I always think in my head, RC column helps me remember. So 2 by 3. Oops. 3. There we go. You guys see the calculator okay, or should I zoom in? That fine? All right, so just punch them in. 1, 1, 0, negative 2, 3, 5. Okay, cool. So once it's inputted, just quit and then go back to the matrix menu by hitting second and the inverse button. Then once inside the matrix menu, you have this section called math. All of these guys are operations for matrices, all of them. RREF will solve any matrix for you without you having to do all that work. So choose the command RREF and go back to the menu and choose your matrix. It will solve it. So as we said earlier, B, which is this B column, is equal to 1. We already knew that, right? So this solved it for us. So this tells us that A is -1 and B is 1. If you go back to the other page, Yeah. Damn, that mosquito escaped. So if you go to the other page here, see how we got b equal to 1, right? This part you said made sense. So if we go back to the original equation, a plus b is equal to 0. If b is 1, what does a have to be?
1.
-1, right? The opposite. So they cancel out. This is what the calculator gave us, didn't it? Right? Because we said the first column is a. So a equals -1, b equals 1. So this solved the whole thing for us. So you could do elimination, you could do substitution, you could do matrix, do whatever the heck you want to do. All right. There's also a website that's not too bad. So I can find it. Oh, here it is. I use this guy randomly when I'm feeling lazy. Can you guys see this? So this is a Gauss-Jordan elimination calculator. Gauss-Jordan is the algorithm that the calculator uses, and also most computer programs, to solve matrices. So it's just some fancy name, some guy's name. So we had a 2x3 matrix, right? We called this column A and this one B. They call it X1 and X2. Who cares? We had what? 1, 1, 0. And then the other one was -2. Oops, that's not a negative. -2, 3, -5, right? So we had, so solve it. A is 1. B is -1. Wait, hold up. May redo that because I don't trust it.
The last part you said it was -5, and I think it was +5, right?
Yeah, you're right. Thank you. I have fat fingers, guys. I'm sorry. There we go. A is -1. B is 1. So you can use this guy too. I don't mind. But on the exam, I'll probably throw in Desmos in there, but during your homework, I'd say use a solver for this stuff, because I am not going to make you solve a matrix by hand, because that is a pain. Once it gets bigger than 3 dimensions, it's just insane. Okay. Sorry, I got a little messy at the bottom there. Forgive me. All right, so it's back to the question, right? So let's see if now their simplified work makes more sense. So first step we said was factor this guy, right? And then we said, if they are distinct, you're allowed to use this rule. You just put A on the first one, B on the second one. And we said that the order doesn't really matter as long as it's an A and a B. Cool. Then the next step we said, use the LCD to multiply every single thing on both sides. So see how this is going to cancel that guy, leaving you with a 5. This will be multiplied on both of them, which left us with this. So they skipped a bunch of steps, right? But you see how they got here now that we did it. Then you distribute, right? Notice how they used a different method. Actually, they did not distribute. They used the Heaviside method. So this method is great and easier, but it doesn't always work. It only works with simple type of examples. So what you can do is say, you know what, I'm going to let x equal -3, which would zero this out. You plug in -3 here, and then you solve for a, because that's what they did. So that's cool. But I recommend learning the other one first. Once you're comfortable with that one, you can learn the shortcut, because you don't want to only learn this guy, because it's not going to work all the time. I like both, but if you only want to learn one, learn the one I used on the paper. If you want to learn both, that would be great. Any questions on case 1?
Yes.
Mhm.
From the a plus b, I'm just a little confused on how you got to it equaling 0. Like, is that just automatically what it is
On here or on my paper?
on your paper?
Okay, let's see here. Oh, this one?
Yes.
So basically, there was no x variable on the left. So because of that, you can let a plus b equal to 0. So when I say equate the coefficients, so basically it's like we're pretending that there's a 0x over there.
Hmm.
So these are the numbers, the constants. So I set these equal to the constant. If there was like an x squared, then I would be looking for x squares. There is no x squares either though. So
Okay.
sometimes there's a bunch of stuff on the left. So this will change depending on the number next to it. So like, let's say there was like a 7x equal to this right here, right? Oh, shoot, this thing's in my way. Just pretend. So let's say there's an a plus b x. So you look at the one that has an x on it. So a plus b would equal to 7. So this would be 7. You see what I mean?
Yeah. Yeah.
These constants equal to 5.
Okay.
5. That's all we're saying.
Thank you.
Mhm. And you'll see more in a minute. In the next couple examples, you'll have a bunch of terms over there. Okay. Let's do case 2. I think that one has some extra stuff. Okay. Biscuits. Case 2. Here it is. So this is repeated linear factors. So if you have a factor that repeats itself, the rule changes a little bit. So you agree that x and x minus 1 are distinct, right? These two are different. These two factors are different. But x minus 1 has a power of 2. So that means it's repeating itself twice. So whenever you have a power on a factor, or a factor that appears more than once, which is the same thing, you would have to have A, B, C and count up until that power. So let's pretend that this was a 4, right? Let's say there was a 4th power. You would have B on the 1st power, C on the 2nd power, D on the 3rd power, E on the 4th. So you'd have to count all the way up until 4. I have a 2, so I count from 1, 2. Does that make sense? What you do when you have a repeated power.
Yes.
Let's do it. Let's do it together. Let me show you. So case 2. Repeated linear factors. Okay. So we have to decompose this guy.
Sir, are you gonna switch to your?
Yes, thank you. Sorry. Appreciate that. Forgot. All right. So first thing, how do I factor this bottom part?
Take 1x out of everything.
Yeah, they all have an X, right? Let's start with that. It's a good idea. Once we've done that, you see how this is a trinomial, and we can factor the way we did the other one, for trial and error, or a formula, however you choose to do it. So I'm going to do trial and error. So x Now it looks weird. That's way out here. Oh, sorry. Give me one moment. Someone's blowing up my phone. Busy right now. Okay, sorry. So what is this going to factor into? X squared minus 2x plus 1.
X minus 1.
Yeah, minus 1, minus 1, right? So -1 times -1 gives me a positive. -1 plus a -1 gives me a -2. So that works. So that's how they got this guy, right? You agree? So what you have to do, so you put the a on the x because it's just a whatever distinct factor. But the one that has a power is a little more complicated. So you got to put a b on the x minus 1 and then a c up until the last power 2. So this is like a 1, 2. So if this was a 3, or let's pretend, right? Don't write this part. You would put one more. You see what I mean? You'd have to go from 1, 2, 3. If it's a 4, you go 1, 2, 3, 4. But we have a 2, so that doesn't exist. That's what you do when you have repeated powers. And the fact that it's a square means it's repeated. Okay. So now, so every case has a slightly different setup. So this is the setup. So now we go back to the algebra steps. So we got to multiply every single one by the LCD. So those steps stay the same. So if you can set up the question, that's most of the credit at least. So try to remember that for sure. Okay. Any questions on this setup? Okay, so let's go to the next step. So multiply, I think we said that was step 1, right? Multiply both sides by the LCD, which in this case is x times x minus 1 squared. So x times x minus 1 squared times 2x minus 3 over x times x minus 1 squared equal to that same LCD, x times x minus 1 squared times the a over x plus, let's just do every single term, guys. A little tedious, but oh well. Life's x. Okay. So at this point, just start canceling things. I ran out of line paper, so forgive me if I'm going at a slant. I'll have some next time. Right, so these will cancel, right? So we told you the left-hand side will always be just the top. So that's easy. So what cancels on the first term right here?
X.
Yeah, just the x, right? So I'm left with x minus 1 squared times a. Cancel one of those. X times x minus 1 times b.
So the last one you take out the whole x minus 1 squared, right?
Yeah, exactly. This is all gone. So I'm left with cx or xc, whatever, same thing. Right? So now at this point, we have a lot of algebra to do. We got to expand this guy, distribute the b. This one's done. But this and this is going to be a little bit of a pain. So step 2, simplify. And group like terms. All right, so I'm going to use a formula to skip a step here. You agree that x minus 1 squared means x minus 1 times x minus 1, right? So that would become x squared minus 2x plus 1. Distribute this x times x times negative 1. That'll give us a next x squared minus x with a b outside. Right? Distribute the a and b, and we'll have ax squared minus 2ax plus a plus bx squared minus bx plus cx. So now we're ready to start grouping after we've done all the algebra. Yeah, that sucks. So any questions on how we got here? Is that okay?
Yes.
All right. So let's start grouping. So anything with an x squared goes together. Anything with an x goes together. Anything that is just a constant goes together. Just one though, right? Yeah. So now step 3, equate the coefficients. So let's do the squares. A plus b. Do you see any squares on the left?
Nope.
So that means that a plus b is equal to 0 for the quadratic terms. Does that make sense? That okay? Notice that all of these have x's. So negative 2a minus b plus c, these are all the x terms. That would be equal to the x on the left. Is there an x on the left?
Yep.
So what is this equal to?
2.
Yeah, 2. And then there's only one constant. So a is equal to what? What's the constant on the left? Right? There's only one, right? Does this make sense? How you set up the system? Or no?
I'm embarrassed by the fact that I don't understand math very easily. So
No, it's okay. That's why we're here. I mean, you guys are supposed to ask me questions, so do not hesitate, please.
I don't even know what to ask.
Did I lose you towards the beginning?
No, you lost me around step 3 somewhere, but I don't know where.
Okay, so let's just start over on step 3 then. So equating the coefficients means, let me show a little more work here. So what you're supposed to do is basically you factor the terms and create these coefficients here. So see how there's this is some number on the x, right? You agree with that?
Mm-hmm.
So you're setting this coefficient equal to this coefficient. So this coefficient is equal to 2. See that? Because this coefficient is 2. This coefficient is negative 2a minus b plus c. That's why we did this.
Okay, that's what's confusing me. Like
then
how that works.
Yeah, that's why it's called this. So we're taking the coefficients and setting them equal to the left-hand side. The way I like to think about it is just, well, there's a quadratic. So I take the numbers, a plus b, there is no quadratic, so I set it to 0. So a plus b equals 0. So it's like I have a 0x squared right here. See what I mean? It's not really there. Constant. There's nothing on it. So a is equal to the only constant. -3. That's where these 3 came from.
Huh.
So that's it. You just set up the system and then you start solving for a, b, and c. Does that help or?
That does actually. Thank you.
Okay. Okay. Let me write this system on the next page in just a moment. I'll wait a bit. Okay, let me try the page. So we had a plus b equals 0. We had negative 2a minus b plus c. There we go. That's what we had, right? So here we don't really need all that much. We don't need anything powerful because we already have a, right? Technically. Check it out. If a is -3, what does b have to be in order to make the first equation true?
+3.
Right, it has to be. So that means we have b as well. So if we have a and b, that means we can solve for c in equation 2, right? Just go ahead and plug them in. So plug these in to equation 2 with my 1, 2, and 3 here. All right. So negative 2a minus b plus c equals to 2. So that'll be negative 2 times negative 3 minus 3 plus c equals to 2. Simplify this garbage. I have negative 2 of them minus 1 more, that'd be 3 of them, right? Oh wait, oh, that's not the same thing. That's BS. That's fake math. That'll be negative 2 times negative 3 is 6 minus 3 plus c. That's 3 plus c equal to 2. So subtract 3 on both sides, right? So let's go over this one more time. I plugged in the negative 3 here. I plugged in the 3 there, right? From these two guys. Once I have a single variable, you can just solve like an old school like equation from middle school, right? 6 minus 3 is 3. Now all I have to do is subtract the 3 on both sides. So c is equal to negative 1. There we go. Are there any questions on the algebra steps? That's okay. So once I have A, B, and C, well, I can just plug that in and we're good, right? That will, like, you know, a lot just happened, right? So what the heck are we doing? We are taking a fraction and decomposing it into 3 separate fractions. That's what we're doing. And then we got to find the A, B, and C that makes it true. So you just plug them in and that's it. That's what the homework is going to expect you to do, to plug in the A, B, and the C. On an exam, I want to see the setup and then some algebra steps like this. Or whatever technique you use. If you choose the Heaviside, that's fine too, but just make sure it works. Okay, so let's go back to the PDF. Let's see if their work makes sense, right? Now that we did the legwork, right? So we had this guy, this rational expression. We factored the denominator like they did. See how they skip like 2 steps right there? Then we use the case 2 technique. So we said, well, these two are different, so just A over that guy, B over that one. But since it's repeated, I have to count up to 2. So A, B, C. Once it's set up, you multiply both sides of this equation here, this equation. Where's my little pointer? This one. Multiply both sides of this equation by the LCD, which is this. And that's what we did, right? Multiply this side, cancel it out, left it with just the numerator, 2x minus 3. Then we multiplied this one on all 3 terms, which canceled a bunch of stuff and left us with these 3 terms. That's what we had as well. We went ahead and multiplied it all out, created our system and solved it. They decided to use the Heaviside method again, which is fine because this is an easier question. But we didn't really have to because we knew what A was. We found B pretty easily, right? We go back to the work here. You see how we knew what A was. Is it clear what B is by knowing A? Did everyone see that? Or no?
Yes.
Okay. So once you have those two, you just plug it in and solve for C. That's all we did. All right. Any questions on case 2? Do you see how to set it up? Does the setup make sense? Because that's the number one main idea. Do you see how they got this? So at least 50% of your grade just for that problem, just setting it up. You guys cool on this part?
Yes, you make it a lot easier.
Yeah, they skipped a lot of steps, right? So over here, any questions on the algebra? Was it okay? Before we move on.
We can email you if we have questions about it, right?
Yeah, anytime. If we forget something, it's cool. Read the notebook to you again. All right. Oh, no, so you guys are cool then. We'll go to case 3 if that's all right. So let's look at what they did. And their black magic. The distinct quadratic factors. So this is a case where one of them doesn't factor. You see that? This guy right here didn't factor. It's called an irreducible quadratic factor. So when you're unable to factor it, you have to use this technique. Basically, you just put a bx plus c on top of it. So you agree that the x minus 1 and the x squared plus x plus 1 are both they're both distinct factors, right? They're different. So case 1 tells you to put a over the first one and b over the second one, but because this is irreducible, you have to do bx plus c. Does that make sense? The setup. This is 50% right here, just setting it up. After that, we get into the algebra stuff. All right, let's get to the example then. Let's do it on another page because these are long. Take a lot of space. Distinct quadratic factors. All right. So this time they went ahead and factored it for us. It's very kind of them. X minus 1 times x squared plus x plus 1. They probably did that because it didn't really factor. So the rule says you just put a over the first one because it is distinct and linear. So that's rule case 1 that I just used. Case 3 says if you cannot factor it, you have to do b. That's an ugly b. What the heck is that? Even English? I mean, I don't know what that is. Fix that. All right. B. Perfect. There we go. Oh, yeah. Bx plus c. So now if this would have happened later, you would have done dx plus e or whatever. Just depends where you are in the alphabet. So whenever a factor that doesn't, whenever a quadratic factor that does not factor down, that's when you type in, that's when you put in the bx plus c or cx plus d or ex plus f, whatever. Okay. Right. So now LCD, so this bottom part. So I'm gonna multiply every single part by this. cancel everything, and then start the process again. So this is the setup. That's the part I don't want anyone to miss, is just setting it up. Oh yeah, it's supposed to write case 2, or step 2.
So step 1 is just put it in that format.
Yeah, this is just setup. And at the end, we can just do a bunch of setup problems just so you can see it a little better. So step 1, multiply both sides by the LCD. Because on the actual questions, all they're going to give you is this part, the left side. Okay. So you got to come up with this and then start the algebra. Okay. So multiply both sides by this. Second one times that. Finally, running out of space. Biscuits. Oh man. Sorry, I have to cram it in there. Can you see that? I'm sorry. This is bx plus c right here. I'm gonna have to put it on the next line or something. Okay, so this continued. I know that looks ugly, but these are getting kind of long. So everything will cancel on the left, right? All gone. On the a term, only the first thing cancels, x minus 1. So we have x squared plus x plus 1 times a. On this one, only that cancels. So I'm left with x minus 1 times bx plus c. So it's time to distribute, right? Simplify and group like terms. Okay. So I'm going to distribute the a, so I'll have ax squared plus ax plus a. I'm going to have to FOIL that or multiply it out. So that will be x times this, x times that, -1 times this, -1 times that. So that'll give us bx squared plus cx, and then negative bx negative c. There you go. So now group everything together. That is the same. There we go. Don't think I missed any quadratics. X and a and b, ax, cx, negative bx right there, a and c. Yeah, very good. Any questions up to this point? Any algebra issues? Okay. So it's time to equate the coefficients, right? You see how there's only, these are the only two quadratics, right? So A plus B is equal to what?
0.
0. A minus B plus C. So this is the X coefficients, right? This equals to what?
1.
1. And then the constants. A minus C is equal to, is there any constants?
No.
No. Any questions on how we set that up? On this one, I would suggest graphing calculator because elimination would be hard, substitution would be hard. And I am lazy. A column, B column, C column. It's a stereotype for math people. They're all lazy. There we go. Okay, so go into matrix form and just solve this guy. The solver, your graphing calculator. You can also solve it by hand if you want, if you remember the matrix steps from college algebra. I'd be fine with that, but it would probably take like a page to do that. If you want to do it by hand. I do not about that life. So let's use the website solver. So what would you say the dimension is of this matrix?
3 by 4.
3 by 4, that's right. So 3 by 4 set. So here are our columns, rows, 1, 0, 0, 1, 1, 1, 0. There we go. So it's the same that we have on paper, right? Solve it, please. All right. So this solves into 1, 0, 0. This is the row reduced echelon form. 0, 1, 0. I'm putting the fractions, but they have decimals. Who cares? 0, 0, 1, 1/3. So if we were to use our graphing calculator, this is what we would get. 1, 0, 0, 1/3, 0, 1, 0, negative third, 0, 0, 1, 1/3. In other words, the first column says A is 1/3. Second row, I should say, not column, row, B is equal to negative 1/3 because B is the only thing left, right? C is the only one left here. So C is 1/3. So those are all the pieces we need to plug in here. Any questions on this? No, any of the steps? One second. Okay. You guys cool then? Case 3. Let's go look at their version, the PDF. There it is. Okay, so same thing that we did, right? A over the x minus 1, bx plus c over that irreducible factor. Multiply both sides by that LCD, canceled everything on the left, leaving us with just x. These all reduce to this guy. Once you're there, expand it and create your system. They chose the Heaviside again, but it does not look easier this time. This time it looks like it was probably worse unless you used a calculator. But either way, it's just kind of shitty. I wouldn't recommend that at all. But anyway, you guys cool on number 3 then, right?
No, can you go back to your matrix solver? Because I did it on the same website and just got a bunch of 1s and 0s.
Okay, let's
Wait.
go. Let's go back there. So you did Gauss-Jordan elimination, right?
Yes.
And then you put 3 by 4, correct? You put 1. Double check that you entered the right numbers.
Mm, 3 by 4.
Let's do it slowly together.
1.
Wait. Sir, on the top one, you had 110 previously.
Oh, yes, thank you. Thank you.
And
You are
yeah.
correct. 1100. That should be a, what the hell? Where'd that go from? 1, -1, 1, 1, 1, 0, -1, 0. Okay. We're good
Is
now,
it
right?
-1 on the third one? Because I had +1 on the third one.
Should be negative. On
On
the third
on-
equation.
yeah, on the third equation, it was +1, 0, +1.
-1,
That's the notes I had anyways.
Yeah, it should be on the notes. It's -1 right here.
-1? Okay.
Yeah, yeah.
Okay, I know where I went wrong, but now it went right. Okay.
You got it? Yeah, I might have maybe you just
Hey.
punched in a weird number. Who knows?
Okay.
But it makes sense. That's
How
what
come
really
that one
matters.
did it in fraction form when previously it did you in like decimals?
Yeah, it is a good question.
That's weird.
I have no idea. Usually it's one or the other, but this time it just completely switched it without telling me why. Huh. Oh well. Magic, that's why. It's magic. All right, let's see here. So any other questions on number 3?
No, I'm good.
I think I just need to do it a couple more times.
Yeah, that'll really help sink it in because you need number 1, what I recommend is just practicing the setup. Like just go through here and say, all right, well, how do I set this up? I don't even care about the solving part. Just try setting up all the cases.
I just want to learn one method and then do that for all of them.
Yeah, you can, well, the setup will be different depending what you have, but the method for solving for ABC will always be the same if you choose to use this method.
All right.
Okay. You do not have to learn 2 methods, but I'll show you the other one for fun if we have time.
Only have the mental capacity for one. So that's it.
I mean, it's just another tool, right? It's like, you can hammer stuff or you could use a power drill sometimes. It's cool.
I'm still smart. I do brain surgery for fuck's sake.
Yeah, it's whatever. I'm sure you're used to using all kinds of tools then, right?
Yeah.
And let's see. All righty. Number 4. So this guy is basically just repeated quadratic factors. So it's a combination of 2 and 3. You see that? We can't factor this. But it's repeated at the same time. So basically, let's try to get a handle on this guy here. So basically it's case 3 combined with case 2. Does that make sense? See how it has a power on it? That's all we're doing. So 4 is really just a combination. It's not anything new. Okay. Yeah, so let's do it. Case 5 is one I don't like. Okay, here we go. Repeated quadratic factors. Okay. Oh, here it is. All right, so again, can't factor it, so I have to put the ax plus b. But since it is repeated, I gotta do it again, all the way up until two. All right. To multiply every single side by this guy. So the same process. So notice how the steps are exactly the same, right? Only thing that changes is the beginning. Now, of course, the algebra is slightly different, but algebra is algebra. So here we go. Okay. So every single term times this. And oh. Can you guys read that?
Yes.
All right. So the cancellation begins. We're left with just the top part every single time on the left-hand side. So we don't really have to think about it. Over here, only one is gone. So I'm left with one of these. Okay. Both of these are gone. So I'm left with this here. Right? Okay. So now we start step 2 right here. Multiply that out. AX cubed plus BX squared plus 4AX plus 4B plus CX plus D. All right, group them together. Looks, no, we're not grouped yet. Double check here. Yeah, that's right. There's only one cubic, so that's by itself. Only one quadratic, it looks like. Plus the x plus the x plus the constant plus the constant. Okay, so now start equating. What's the first equation going to be?
AX cubed.
Yeah,
AX equals 0.
yeah, so the cubic part is 0. Okay. And then the quadratic?
B equals 2.
B equals 2. Yeah, that's right. Now there's only 2 parts of the next, so what is this one equal to?
Eight.
Oh, this is the X ones.
Oh, 1.
1. Yeah, there you go. The other one's 8 though, right? Oh man. Is this supposed to be a B? There we go. Okay. That seems doable, right? Because we got, if A is 0, right? That means C has to be what?
1.
Yeah. What is B gonna be? Oh, actually we have B. If B is 2, what is D? Now, if you can't do it in your head, that's fine. Just plug it in and find out, right? 4 times 2 plus D equals 8. 8 plus D equals 8. Subtract 8. D is actually 0 as well. You could also use the matrix if you wanted to. But notice how the first equation only has one variable, right? So if we were to have used the matrix, this is what you have needed to do. 1 for the A, but then there's no B, C, or D, right? Equal to 0. This has a 4, no B, a 1C, no D. Ah, crap, I forgot that one. Darn it. Dang it, dang it. 1 second. 0, 1, 0, 0, 2. Okay. 4, 0, 1, 0, 1. 0, 4. There's a 4 there. No C, 1D. So you could solve this guy and you would get these two if you wanted to. But so it's a little weird setting it up because there's no A, B's, or C's. So you have to remember that those are zeros. And this is A column, B column, C column, and D column. So you can still use that method, doesn't matter.
What's the method you used before that, though?
I don't know, actually. I don't know if it has a name, but basically it's since I had, oh shoot. Basically, since we had this equation here and we knew what A was, we could solve for C just straight up using just our equations, right? Because this is 0, so C has to be 1. You see that? So we got A, B, C. Once we have all three, you can plug in the B and find the D. And that's what we did here. So if you can kind of eyeball it and notice that you have enough information to just solve it quickly, go for it. Or if you want to go straight to the matrix and use a solver, then that's fine too. I don't care. It's up to you. Just don't forget that the final answer is plugging all this stuff back into here, right? I haven't been doing that just because I'm running out of space. Okay. You see what I'm talking about? Any questions on 4? Okay. All right, case 5 is the one that really sucks. I should be honest with you. Let me show you why. So case 5 happens when the numerator has a higher degree. In other words, you have an improper fraction. So you guys remember what degrees are, right? Or no?
They're like the 3 above the X right there.
Yeah, the highest power of all three would be the degree of the top. So 3 is the highest, so that's the degree. The bottom degree is 2, right? So since the degree of the numerator is 3 and the degree of the denominator is 2, then we have case 5. So whenever this happens, you have to do long division. And that stuff is difficult if you haven't done it in a while. Let's go ahead and do it, I guess. This will be probably our last example because it's kind of long for the night. And because I'm sure we're all about to pass out. At least you'll sleep good, right? Just thinking about math problems. The rational expression is an improper fraction. Okay, here we go. So do you guys remember how to do long division on paper?
Can you switch your views?
Yeah, let me do that
Thank you.
right now. All right, let's start. I'm going to review long division. I don't mean to insult your intelligence, but it's going to help, I promise. So you guys remember when we did 5 divided into, let's say, 595, right? The rule was you check if 5 goes into the first term, right? You put a 1 up there, goes in 1 time, right? 1 times 5 is 5. And then you swap the sign and you subtract. 5 minus 5 is 0. Then you bring the 9 down and start over. So this is the algorithm that we're going to use. This is the pattern. Divide, multiply, subtract, divide, multiply, subtract. You just keep doing that. 5 goes into 9 1 time. 1 times 5 is 5. Subtract 4. 5 does not go into 4, so bring down the 5. 5 goes into 45 9 times. This, you guys remember this?
Yes.
Okay, so basically we're going to do that until we get a remainder. The only thing is we will not have any numbers and it will all be algebraic, but the pattern is the same. I guess let's go ahead and finish it, right? So here we go. So what I want you to do is divide into this guy. Oh, there's actually a step. Before you start dividing, you need to make sure that you have every power in descending order. Notice how the stuff we're dividing into does not have a quadratic. You see that? We have to add it ourselves. That's 0 x squared. Okay. This is how you start your long division. The only difference is you only divide with this term. You don't need to use the whole thing. Okay. So x squared goes into x cubed how many times?
1 time.
Right. And then if that sounds weird, just go ahead and do it yourself. X cubed divided by x squared, that's an x, right? A single x, one x. That makes sense?
Sort of.
Now you see how we divided these? X squared went into x cubed. They canceled out, right? Do you remember how to reduce these?
No.
So when you divide the same base, right, we would just take the number 3 minus the 2, leaving us with a single x.
Oh, okay.
In other words, if you have 3 x's and you divide by 2 x's, you have a single x left, right? So that's what we're talking about back in the day. That's why there's a single x here. So now the pattern restarts, right? 1 times 5, x times x squared is x cubed, correct? You see the pattern?
Can you repeat that?
This part? Or this?
That part.
Yeah, so remember how we did the 1 times 5 and then we put 5 here and then we put a minus on it?
Yes.
So x times x squared is x cubed.
Okay. Thank you.
But let me show the whole thing because I forgot a step. That wasn't wrong, but I want to show you more details. So x times x squared is x cubed, x times x. So you have to actually multiply every single piece. X times -2. Okay. But remember we said we have to subtract it. That's the pattern. So we have to distribute a negative to all of the terms. So that makes it a little more complicated, I guess. You guys still with me up to that point?
Kinda.
Right, everyone saw we got the x, right? So then we
Yes.
multiply all these 3 by the x. So that's where these came from. Everyone see where these 3 terms came from. If not, I can do some side work if you want. Just let me know.
I'd love that actually, if I'm being honest.
Yeah, let's do it. So
Sorry, guys.
X times x squared plus x minus 2, right? Because I'm multiplying this times all three terms. X times x squared, x times x, right? X times a negative 2. So that's where all this came from here. Okay. Let's just distribute the x right there. Oops, dang it. Made it disappear by accident. Okay. All right, so now just put a minus on it, just like we did the 5. So x cubed minus x cubed. So just so it doesn't get messy, I want you to remember that I'm going to subtract. I'm going to do the opposite of whatever is inside, right? That's what the minus means on the parentheses. Is that cool? Right, you guys all see that this means I got to swap all the signs, right? So,
Yes.
okay. X cubed minus x cubed is going to be 0. Is that clear? Zero minus x squared is minus x squared. Negative x minus a minus 2x, that would be plus 2x, right? And if this is weird, you could do it this way. You can say, you know what, I'm just going to go ahead and distribute the negative inside and do this. Minus, minus, plus. So x minus x, 0 minus x squared, negative x plus 2x. Is that better, or is this still weird?
That was better.
Okay. So just remember that when you do this step, you have to swap them all. Okay. Like just like we swapped the 5 into a negative. All right. So now we start over, right? The step we just got to is when we bring down the 9. So I brought down the 3 right here. So now does x squared go into x squared? Yeah, right. How many times?
Once.
Yeah, so, and if we don't see it, just do it. Negative x squared divided by x squared would be -1, right? So we have, it goes in there one time, or a negative one time. So now -1 times all 3 pieces. So they're just gonna swap signs, and then I gotta swap them back. That's kind of silly. All right, minus. So now I'm gonna swap them, plus, plus, minus. Now we do the math here. Negative, plus, right? 1 plus 1, 3 minus 2. And we're done, because x squared is now too big to go into here, right? So if you remember this, it's the same thing. It's just that we have to do it in algebraic form. It's a little bit of a pain.
What's
See,
that symbol in front of your x squared right there?
it's a plus.
Oh,
I
Sorry.
swapped it. Yeah, it looks a little messy.
not sure what I'm looking at, to be honest. What was it originally?
All right, so let's show that step again. It's all good. Originally, before any kind of swap, it was -1 times all 3 terms. Negative x squared minus x plus 2. And then you got to put the negative in front. That's the original. So then you multiply the negative inside, which is swap all your signs. And then you add them together to get the 2x plus 1.
Thank you.
All right. So now, how do you write a remainder? Do you remember? Because this is the quotient, right? The top part.
So write a remainder, don't you just write the R and then the whatever the remainder is? Or
Yeah. I mean, that you're not wrong, but there was an extra step. We would write it as a fraction. Do you remember that? If we had remainder 2, that was the same as saying 2 over the divisor. So, like, let's say there was a remainder 10 there, right? Here, you would say the answer would be 119 plus 10 over the divisor. But of course, that doesn't make sense because 10 is divisible, but that's how you would do it. So on this one, this is what we're going to do. Let me show you. All right. So the whole purpose of all this, right? It's a long process, is to divide this out to get something that is no longer a improper fraction. So I get x minus 1 as a quotient plus the remainder over the divisor. So that was the goal, is to rewrite the fraction. Once it's rewritten, you can apply partial fractions to it. But we're out of time, just about. Okay, so before I let you go though, let me find some quick partial fraction examples.
so in this
Sir.
one,
Oh, you go first.
so okay, what was the original
For this one?
problem? No, like the x cubed. Did that have the equal x minus 1 or no?
Yeah, it's in the, here, let me show you. It's right here, the PDF. So it starts like this.
Okay.
So then we have to do the division, which gets us to here. Notice how they showed us no work whatsoever. They just said, no, it's just this, man. It's cool. Once you get there, you have to do the long division or the partial fraction. So these are, you factor this part and you do the distinct linear factors.
Okay, so after you long division part, the problem becomes the remainder over the original bottom part of the original bottom part.
The original divisor, right?
Okay.
Okay, so that's the part that has to be decomposed.
So you only decompose this, but the entire solution will contain this first part plus the decomposition. So that would be right here, the answer. But those are the harder ones. Make sure you get the cases down before you start doing that type of stuff.
So what was the final answer for that?
We don't have time to finish it, but it's this right here. This one. So once you do the long division, you then do decomposition and you get this.
Are you going to go over that the next time? How to get the answer?
Yeah, sure, we can.
That'd be nice.
No, yeah, no big deal. Let me see. You got this part or no? Well, I guess I did send you the PDF. Make sure you download it, guys. And if you can't, let me know.
That whole thing is the final answer.
Yeah, so they decompose the original into these these 4 terms.
So you know how it says therefore? It could be either that one or the bottom one, right? The answer. That's how you would write it.
You mean this one?
Yeah.
Well, this one is before the decomposition.
Oh, okay. And then the final answer is the bottom.
Yeah, so if
Okay,
the only this is the long division part after right after long division, and then this is the decomposition. To that, there's still work to do on that guy, but see if I can find some quick stuff. I don't think we have time though.
On your thing right here,
Mhm.
it's supposed to be a positive, like an x cubed plus x, right? And then -2 on the top,
Here or
Up.
here?
all the way to the top, like kind of
Here.
to the right. Yeah, to the right. Keep
This
going
one.
to the right. Yeah, right. Plus
That should be
X.
plus. You're right. Thank you.
Yeah, that's where I got like kind of confused. Like, whoa.
Yeah, no, thank you. You're right. I just missed a sign there.
Okay. All right.
Okay, so yeah, I guess we'll stop here. We can talk more about it next time and try to remind you what we did. You guys have any questions on case 1 through 5? Now, please look over that PDF and have some dreams about it if you can. And
Why is the PDF so bad though?
what's up? Did it not load?
No, it's just so bad.
Also, does it look weird?
It just like it's a lot more difficult to understand than what you went over.
Oh yeah, that's what I'm telling you. The math books skip so many steps. They just assume that you're all algebra masters, which is not fair.